Welcome everybody to Quadratic Functions and Equations lesson number 6. So today we are looking at solving quadratic equations, and we're going to look at a new way to do that. So we're going to use something called the quadratic formula. I will be skipping a bunch of parts in this just to keep it short and succinct. So it says here, in previous lessons we have determined the roots of quadratic equations by graphing and by factoring using inspection or decomposition. So in this lesson, we are going to use the square root method, the completing the square method, which we learned last lesson, and the new one, the quadratic formula, to solve these equations. So what I'm going to do is skip over the review. We don't need to remember how to factor. We did a whole unit on it. And it wasn't that long ago. So let's look at the square root method. So it says here, the solution to the equation x squared equals k is found by taking the square root of each side to get x is equal to plus or minus root k. So we're going to use the square root method to solve the quadratic equations. So what they're wanting you to do here is just solve for x, right? Let me just scroll up a little bit. Or I'm going to just draw. There we go. So we're going to solve for x here, and in order to do that, we have to divide both sides by 3. Then we get x squared. I guess I should slow down a little bit. X squared is equal to 27 divided by 3 is 9. Now we can take the square root of both sides. And we know on the left side it's going to be x, but on the right side it's plus or minus root 9. Luckily, root 9 is a perfect square, so it's going to be plus or minus 3. That means that the roots are 3 and negative 3. And we can use that same idea when we have perfect square binomials as well. We've done this before. So here I have 2x minus 1 squared is equal to 64. So I can take the square root of both sides to get rid of that exponent, or that's 2 exponent there. So now I have 2x minus 1 is equal to plus or minus the root of 64. And we know that the root of 64 is a perfect square, which is awesome. So plus or minus 8. So now we can solve this 2 different ways. We can say 2x minus 1 is equal to 8, and 2x minus 1 is equal to negative 8. So we're going to solve them the same way. We just have different numbers now. Add 1 to both sides, and we have 2x is equal to 9, and then we're going to divide by 2 to both sides, and we get x is equal to 9 over 2. On the other side, same process. Add 1 to both sides. 2x is equal to negative 8 plus 1 is negative 7. Then we're going to divide 2 from both sides. And we're left with x is equal to negative 7 over 2. And the last one we have x plus 3 squared minus 8. So the first step we're going to do is to add 8 to both sides. And now we have x plus 3 squared is equal to 8. Now we can do our square root to both sides. And we have x plus 3 is equal to plus or minus root 8. In this case, square root of 8 is not a perfect square, or it won't become an integer, or a whole number. So we're going to leave it like that. And then what we can do is just subtract 3 from both sides. And now we have x is equal to negative 3 plus or minus root 8. My pen's a bit laggy today. I apologize. And then we can just reduce that root 8 to root 4 root 2, or 2 root 2. So x is now going to be negative 3 plus 2 root 2, and negative 3 minus 2 root 2. Those are our two values right there. So this is the square root method. We can look at completing the square method. Each of these kind of works in different scenarios, and then the one we're exploring today is going to work in all scenarios, which is nice. Explain why the quadratic equation 3x squared minus 12x minus 8 equals 0 cannot be solved by factoring. So if we wanted to factor this, we could use decomposition, and we would say 3 multiplied by negative 8 is negative 24. So if we have negative 24, we're looking for two numbers that multiply to negative 24 and add to negative 12. And we could go through all of those factors here, but you're going to realize that none of them are going to multiply to negative 24 and add to negative 12. So can't find, the reason that it doesn't work is because we can't find two integers that add to negative 12 and multiply to negative 24. So we can solve it by expressing the left side in complete square form and then using the square root method. So the square root method works really well if you're starting with standard form equation. But here we're starting with a general form equation, so what we have to do is complete the square. So convert this into basically standard form using completing the square and then solve. So it's a bit of a pain in the butt. It works really well if we start in standard form. So we can still complete the square. We have 3x squared minus 12x minus 8 is equal to 0. So we have a constant out front here when we complete that square. So what we're going to do is group those first two and factor that constant out. What we get is 3x squared minus 4x minus 8. And then we are going to take half of negative 4, which is negative 2, and square it to get positive 4. So now we have x squared minus 4x, and we're going to complete the square by adding 4 and subtracting 4. Minus 8 is equal to 0. And then we want to move that one out of the brackets. When we do that, we have to multiply it by the constant. So negative 4 times 3 is negative 12. And then we can rewrite this as a binomial, perfect square binomial, because we're going to have x minus 2 squared, and then minus 12 minus 8 is negative 20 equals 0. So that is our equation in standard form. And now we want to use the square root method to solve it. So we have 3, I wish that lag in my pen would go away, x minus 2 squared minus 20 is equal to 0. Okay, I'll fix that after this video. So we're going to add 20 to both sides. So we get 3x minus 2 is equal to 20. And then I'm going to divide 3 from both sides. And now I've got x minus 2 squared is equal to 20 over 3. Square root both sides. So now we have x minus 2 is equal to plus or minus the root of 20 over 3. And then we're going to add 2 to both sides. So that our final answer is x is equal to 2 plus or minus the root of 20 over 3. So you can see that the square root method is really effective if we start our equation in that form. But if we have to convert from general form into that form, there's this whole other process we have to do here. And it takes a while. Luckily, there's a way for us to factor trinomials in general form that seem unfactorable. And we're going to use something called the quadratic equation. So the quadratic formula. This page shows you how it's built. I'm not going to go through that. If you really don't believe that it works, I can show you, or that it's an actual thing, I can show you the proof. But for now, we're just going to scroll to the next page and look at the quadratic equation. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So what are a, b, and c? Well, it tells you right here, but in the form of the equation a x squared plus b x plus c is equal to 0. The constant in front of the x squared term is your a, the constant in front of the x term is your b, and the constant at the end is your c. So if you can't factor this, you can always use the quadratic formula. Even if you can factor it, you can always plug it into the quadratic formula and you will get roots. You will get answers. So let's do a couple here. So in example A, we know that we're looking at ax squared plus bx plus c is equal to 0. So in this case, I'm just going to scroll a little bit. A is equal to 1, b is equal to 2, and c is equal to negative 1. So what we can do is now we can fill out our quadratic equation. X is equal to negative b, so negative 2, plus or minus the square root of b squared, 2 squared, minus 4 times a times c. 4 times 1 times negative 1. And then all of that is divided by 2 times a. And now we just need to solve. Just going to scroll up and give ourselves some room here. So I'm going to simplify everything under my square root sign. So I have negative 2 plus or minus the square root of 2 squared is 4. 4 times 1 is 4 times negative 1 is negative 4. And it's all over 2 times 1, which is 2. And now we can simplify completely what's underneath the square root sign. 4 minus negative 4 is 4 plus 4. So we have root 8, all divided by 2. We can convert root 8 into 2 root 2, all divided by 2. And then you can see that this can also be written, oh, what did I do? Hopefully we're still recording here. This can also be written as x is equal to negative 2 over 2 plus or minus 2 root 2 over 2. And then negative 2 over 2 is just negative 1 plus or minus, those 2's cancel, so we have negative 1 plus or minus root 2. And so when we type that into our calculator, we get x is equal to negative 2.4 and 0.4. Because out of this we have two equations, right? Negative 1 minus root 2 and negative 1 plus root 2. All right, let's go up and do another one. Oh, geez, sorry, it's super laggy right now, so I can't tell if I'm scrolling too hard. I'm gonna do this example, And I'm going to do the start of this one and show you how to start it, and then I'm going to call this one a day here. So in this case, we have A is equal to 4, B is equal to negative 12, and C is equal to 3. I would suggest doing that every time, just so you keep them straight. And then I'm just going to make sure I have the formula in front of me so I can fill it out properly. X is equal to, and if you don't have that in front of you, I would suggest writing it on your page and then filling it in. So we're going to go negative B plus or minus square root of B squared minus 4AC, so 4 times 4 times 3, all over 2A. So we just need to start simplifying. Okay, go away. There we go. So the first term is negative or minus negative 12, which is going to just leave us with positive 12, plus or minus, well, negative 12 squared is 144, and then we're going to subtract 4 times 4, or let's do 4 times 3 is 12, times 4 is 48, all over 2. And now we're going to say x is equal to 12 plus or minus root 96 over 2. Most problems or most mistakes are going to come just from the process of this, just missing a negative or multiplying things incorrectly. So just be careful and do this process nice and slow and double check everything. We can rewrite 96 as plus or minus 16. Shoot, sorry, I wrote that wrong. Root 16, root 6. That's what I was going for. Root 16, root 6, all over 2. And then we know that is going to be 12 plus or minus 4 root 6 all over 2. And so we can say, I'm taking up a lot of space here, 12 divided by 2 is 6, plus or minus 4 divided by 2 is 2 root 6. So that gives us 2 roots, 6 plus 2 root 6, which is going to be 2.7, and 6 minus 2 root 6, which is going to give us 0.3. Those are our 2 roots right there. This one, I just want to talk about how to start this one. So you can see that we don't have it in the form that we want. We want it to be a nice ax squared plus bx plus c trinomial. So we have to do a little bit of expanding first. So what I do here is multiply that 3 in. So now we have 4x squared is equal to 12x plus 15. And then you can just do some algebra. So I'm going to subtract 12x from both sides. So I'm left with 4x squared minus 12x is equal to, did I write 18? I meant 15. Oh, that must be a 5 with just a leg. 15. 15. And then subtract 15 from both sides. And now you have 4x squared minus 12x minus 15 equals 0. You know your a is 4, your b is negative 12, and your c is 15. And now you can use the quadratic formula to find your roots. Cool. I'm going to leave that one there. This is one of the main lessons from this whole course, so please be comfortable with the quadratic formula. It can be used to factor any trinomial. So on any test, if you can't remember decomp or you can't remember inspection, you can always use this. It's a lot longer than both of those processes, and there's a lot more room for error. So it's not something that you want to be using every time, especially if you can use like something like inspection, which is way faster. But it does work. So, and it's a formula that you don't have to memorize, but you'll use it enough that you will memorize it. So yeah, thanks for watching. Don't forget to like and subscribe.